Okay, so look here. From tomorrow we will move on to shock waves. Today we will solve problems related to oscillations chapter. Okay, the problems coming from oscillation chapter. Okay, and today I had sent one PDF file. Earlier also I had sent, but in that PDF file what happened was this problem, second problem was wrong. So I had sent one PDF file, say some 1 week back, 1 week or 6 days back. In that, this problem that has been worked out, second, that is actually wrong. Therefore, this one I have replaced it by the correct solution, and the correct solution is given in the last page. Okay, the correct solution is given in the last page. It's the same problem too, but the correct solution is given in the end. Okay, that's all. So therefore incorporate this where this has been mentioned. Okay, clear? Okay, now we'll move on. So use this file, that is enough. Okay, now look here, before we do anything, first we have to know we have to compile the list of all important formulas that we will be encountering. Okay, so is the screen visible to you all? Text and all visible, right?
Yes, sir.
Okay. Okay, so look here, there are roughly some seven problems, sorry, 7 formulas. So we'll walk through it and we will solve one problem after the other. Okay, first, as usual, the first thing, look here, the first formula is the spring constant K is given by, so what is the definition of spring constant? K is equal to force per unit extension as per Hooke's law. Okay, what is the first formula given by? The first formula is given by spring constant K is equal to, the spring constant K is equal to force per unit extension. Okay, as per Hooke's law, force is minus Kx. So if you consider only the magnitude, then the expression for the expression for spring constant is given by what? K is equal to force by extension. What does this force represent? Force will refer to restoring force, or if there is a mass that has been attached to the spring, that force will refer to mass into acceleration due to gravity, m into g. Okay, here what does F stand for? F stands for the force acting on the body. X will give you the extension produced by the spring. Okay, that's what has been given here. What is X? X is the extension produced by the spring. Then if the mass is suspended to a spring, then the force F will be equal to mass into acceleration, that is weight acting downwards. Okay, mass into acceleration due to gravity. So F will be equal to m into g, where m is the mass of the body and g is the acceleration due to gravity. So which, if nothing is mentioned, we will take it as 9.8 meters per second square. This is clear. This is about the first formula. Okay, what is the first formula? The expression for spring constant is given by K is equal to force by distance. Force by distance. That is what is given here. Okay, next, what is the second formula? The time period of oscillation of a spring is given by, so if a mass m is attached to a spring of spring constant K, and if that spring is set into vibration, so it will execute to and fro motion. The time period of the oscillation is given by what? T is equal to, the time period of oscillation of a simple pendulum is given by T is equal to, this is second formula, T is equal to 2 pi into square root of m by k. Okay, what is the second formula? T is equal to 2 pi into square root of m by k. This is the second formula. Okay, this will be the second formula, which helps us to find the time period of oscillation. Okay, next, look here, what is the third formula? Third formula is the angular frequency omega of oscillation. The angular frequency omega of a simple harmonic motion is given by omega is equal to, this is the third formula. What is the third formula? Third formula is angular frequency omega will be equal to 2 pi divided by time period, or it will be equal to 2 pi into linear frequency, 2 pi into f or 2 pi into nu, in whatever way we denote the linear frequency as. Okay, so therefore this will be our third formula. Okay, next, what is the fourth formula? Fourth formula talks about linear frequency. So the frequency of oscillation is given by, so what is frequency given by? Nu will be equal to, nu is equal to, this is the fourth formula. The linear frequency is given by nu is equal to omega by 2 pi. Okay, or it is same as writing, okay, so this will be equal to omega divided by 2 pi, or it is same as telling, suppose I choose red color, it is same as telling that it's same as telling that omega is equal to 2 pi into nu. They are one and same. Okay, omega is equal to 2 pi into nu, or nu equal to omega by 2 pi. It's all nothing but the same equation put in different form. That's all. Okay, this is the fourth formula. Next, what is the fifth formula? Look here. If two or more springs are connected in series, so if two or more springs are connected in series, then the effective spring constant for series is given by what? 1 by k is equal to 1 by k effective is equal to 1 by k1 plus 1 by k2. So what is the fifth formula? I will call this as 5a. It's called as 5a. Means what? So what does that mean? If two springs are connected in series, then the effective spring constant of that series combination, it's given by what? 1 by k effective is equal to 1 by k1 plus 1 by k2. 1 by k1 plus 1 by k2. Okay, this is clear. So if three springs are connected in series, then you have 1 by k effective is equal to 1 by k1 plus 1 by k2 plus there will be 1 by k3 coming here. Okay, 1 by k3 will come into picture. 1 by k3. Okay, so for two springs, this is the formula. Okay, next, if the springs are connected in parallel, then the effective spring of the parallel combination is given by what? K effective is equal to k1 plus k2. K effective is given by k1 plus k2. This is formula 5a. This is formula 5a. This is formula 5a. This is 5b. This is for series and this is for parallel. Okay. Next, look here. Next, if a particle is executing a simple harmonic motion, then the displacement of the particle x at any instant of time t, I already told. Okay, I also showed a video that the displacement of a particle executing simple harmonic motion can always be represented by a sinusoidal signal. Therefore, the instantaneous displacement of the particle x at a time t. At a time t means it's actually x is a function of time. Okay. Okay, x is a function of time means what? Look here. Can people see here? Look here. X is going to be a function of time. Okay, x means it actually refers to what? X is a function of time. Okay, here in my formula, I've simply written it as x, but it's actually a function of time. So what is the displacement at any instant of time given by x of t is equal to a into sine of omega t. Okay, so if I put it here, so the displacement of the particle at any instant of time that is executing simple harmonic motion is given by x of t is equal to a into sine of omega t. And what is the velocity of the particle given by? Velocity will be equal to dx by dt. So if you differentiate, what you are going to get? Dx by dt is equal to a into d by d of sine theta is cos theta. D by dt of omega t is what? Omega. Therefore, the velocity of the particle is going to be a omega into cos of omega t, that is given here. Okay, the velocity of the particle at any instant of time, so that is given by v is equal to a into cos of omega t. I think I'll take from here. V is equal to dx by dt, which is equal to, okay, so what is the velocity of the particle that is executing a simple harmonic motion given by the velocity of the particle that is executing simple harmonic motion? If this is the displacement of the particle, velocity has to be this. Velocity has to be this, a omega into cos of omega t, which is the velocity of the particle given as a function of time. Okay, next last formula, yeah, last formula is for a body that is vibrating, for a vibrating system at resonance, what happens? The frequency of the applied force will match with natural frequency of vibration. Okay, for a particle that is in resonance, the applied frequency will match with natural frequency of vibration. Natural frequency might be given by this expression. Okay, so for a particle at resonance, natural frequency of vibration will be equal to the applied frequency, and natural frequency may have any one of this expression. Okay, what is that? It may be either this omega or time period t or f. Okay, this may be the equation connecting the natural frequency or natural time period. Okay, clear to you all? This is about the list of formula. I think I'll close this. When I require, I'll open. So then doc file also I don't require for now. Yeah, this is clear. So these are the 8 different formulas. Which are the 8 different formulas? So the 8 different formulas are, look here, these are, this is the first one, this is the second one, this is the third one, this is the fourth one, then fifth, then you have 5a, 5b, then you have displacement and velocity given by, then you have natural frequency will be equal to applied frequency at resonance. Okay, this is clear. I think now we'll move on to solving the problems. So I don't require these stuffs now. Okay, now with these formulas, now we can start solving our problems. Okay, I will just inform you all, I just want to give a general word. Look here, in our VTU examination, whether it is first sem, second sem or higher sem, okay, all problems of any subject, they will all be based on direct substitution. Okay, understood? 99% of the time the problem posed are going to be direct in nature. Okay, only very rarely, only very rarely you will find a problem will be twisted. So therefore, if you just know the list of formulas and how to apply them, so you can easily solve all the problems. Okay, so therefore look here, don't panic, just be thorough with the list of formulas, and also all the problems that is given in the examination is going to be direct substitution, therefore all people can easily solve it. Okay, understood? So with this we will move on to the first problem. Anyone has any doubts so far? People are having any doubts? No? Okay, so shall we move on to solve the problem? So kindly have calculator with you. Okay, kindly have calculator with you. So okay, so incidentally, when I was working out this problem for C section, this problem, the second problem, so one of the student had actually pointed out a mistake. Okay, so therefore the solution was wrong. So therefore, even though it is worked out, I might have also made mistakes. So if I had made mistake, kindly let me know. Okay, now shall we move on to solving the problems? Yes.
Yes, sir.
Okay, so let us look at the first problem. Okay, what is the first problem? Look here, a man weighing 1200 newtons, he steps on a spring. Okay, let me. Okay, what is the statement of the first problem? Statement of the first problem is a man weighing 1200 newtons steps on a spring balance. So when he steps onto a spring balance, what will happen? The spring is compressed. The spring in the machine is compressed by 2 centimeters. So with this information, you have to find the force constant of the spring. Okay, what does that mean is understand the statement of the problem first. What is that? A man weighing 1200 newtons, he stands on a spring balance. Okay, generally we all know what is that. There are spring balance or weighing machine. Weighing machine are used to measure the weight of a person or weight of objects, correct? So when this man who happens to be of 1000 newtons, a man weighing 1000 newtons, when he steps onto a spring balance, so the spring gets compressed by how many distance? 2 centimeters. Okay, so what is our goal here? To know the weight of the person or to know the characteristic of the spring? We have to know the characteristic of the spring. Okay, once again I'll tell the statement. What is the statement? A man weighing 1200 newtons, when he steps onto a spring balance, the spring in the machine gets compressed by 2 centimeters. With this, what you have to find, what we are supposed to find is the force constant of the, you have to find the force constant of the spring. What you are supposed to find, the force constant of the spring. Is the statement of the problem understood for all? The statement of the problem, were you able to understand? Okay, look here. The first problem only I will take lot of time to solve. Okay, but at later stages I will directly get on to my syntax. Okay, now look here, how to solve this problem. First, this is the general approach that is applicable for any problem that you want to solve. What is that? Whenever a problem is given, you cast it into three stages or 3 events. Okay, what are those 3 events or what are the 3 things? The 3 things are: 1, you just list out all things that are given to you. List out all things that are given to you in the problem, in the statement of the problem. List out all that. That is a given part. That's the first part. What is the next part? Next part is list out all the things that you have to find out. That will be this second step. What is the third step? Third step is you will look at how to solve it or the solution part. Therefore, what are the 3 stages what are the 3 key steps that are involved in problem solving? The first step is going to be list out all the given things, list out all the things that is given to you. Second thing will be list out all things that you are supposed to find. Third thing is going to be how you are going to find the given quantity in question in terms of known quantities. So that will be the solution part. Okay, that will be the solution part. So therefore, likewise, in this problem, what are the things that are first given to us? The things that are given to us is the following. Okay, so I will erase. I think I don't want this. Okay, look here. What are the things that are given to us? The things that are given to us is, what are the things that is given to us? What are the things that is given to us is weight of the object is 1200 newtons. Next, when he stands on the spring gets compressed by what distance? Look here, the spring will get compressed by 2 centimeters. By 2 centimeters. Therefore, what is that going to be? X will be equal to 2 centimeters. Okay, now before that, so spring is going to get compressed by 2 centimeters. Okay, now I want to ask you people the following. Okay, all of you know in your handset, it will have 128 GB hard disk space, RAM is some 8 GB RAM, and so on. All these things we know, right? Now the basic question I want to ask is, suppose I consider a computer's RAM, random access memory. Okay, one happens to be of 256 MB. The other RAM happens to be of say 2 GB. Okay, out of these two, 256 MB and 2 GB, which one has a greater memory? 256 or 2 GB? Which one has a greater memory? Sushant, EC117, can you tell, man? Which one has a greater memory, man? 256 MB or 2 GB? 2 gigabytes. Which one is more? People are there.
GB, sir. GB, GB.
Which one has more memory?
2 GB, sir.
2 GB. You all agree with me, no? What about
Yes,
256?
it's comparatively less, sir.
But 256 is greater than 2
So, but that is MB and this is GB,
MB.
sir.
Yes. Okay. I think people are people are able to grasp the point I'm trying to highlight. Okay. What does that mean is, when you list all the data, okay, look here, when you list all the data, when you list out all the data here in this step, always convert everything to SI units. Understood? Is it clear? Convert all your data into SI units. Okay. So to the problem, to the question that I posed to you all, 256 MB. That RAM is very much small when compared to 2 gigabytes. That is 2 into 10, 2 into 1000, 2000 bytes. So 256 MB is quite small when compared to 2000 bytes. I think it is 2 into 10 power 6, I suppose. Okay, clear? Is this clear? Therefore, in this problem, what did I do? I listed out all the given quantities, but I have also seen to it that they all are converted into SI units. Is it clear? Is it clear to you all? Okay, what is step 1? List out all the things that you want to, that is given to you. And when you do it, what you have to do? Convert all those specifications of your problem into SI units. Express them in terms of SI units. Okay, step 1 is done. Next, what I have to do? I have to find the spring constant K. So that has been listed here. So what we have to find? We have to find the spring constant K. Spring constant K is listed here. Yeah, spring constant K is listed here. Okay, the spring constant K is listed here. Okay, this is the second part. What is the third part? Third part is how you are going to find the spring constant K with the help of given data. So therefore, what is the solution? Look here. So what is the formula for spring constant given by? It was the first formula. What is that? K is equal to omega by x. K is equal to omega by x. So look here. I'll put it here. So you know that omega K is equal to W by X. This is the formula for spring constant, and all the values are directly given in SI units. Okay, 1200 is already in newtons. Then 2 into 10 power minus 2. This is already in meters. Okay, now will someone work out and tell me what is this answer going to be?
So 6 into 10 power 4. 6 into 10 power 4.
6 into
10 power 4.
Okay, correct. Okay, I think it is clear. One simple check is, look here. 2 6 are 12, 2 1s are 2. So therefore in numerator you will have 600. When this 10 power minus 2 goes in the numerator, it's going to be 600 into 10 power 2. So therefore final answer is going to be this. Okay, final answer is going to be K is equal to 6 into 10 power 4 Newton per meter. So what is the final answer? Final answer is going to be the effective spring constant of this spring is 6 into 10 power 4 Newtons per meter. Okay, this is clear. This is about the statement of, this is how the first problem is solved. Okay, now shall we move on to the second problem? Okay, I think now we will move on to the second problem. Okay, so in the second problem, what happened? So I think I don't require in this. I'll clean up my paint object. So what is the second problem? Second problem is this. Okay, so what is this? A mass of 15 kg. Okay, what is the statement of the second problem? The statement of the second problem is a mass of 15 kg, 15. So it is suspended from the free end of a spring. When set for vertical vibrations, the system executes 200 oscillations in 80 seconds. So calculate the force constant of the spring. Okay, again I'll read out the statement of the problem. What does this problem tell? This problem tells that a body of mass m, a body of mass 15 kg is suspended to a spring from one end. Then when it is set into vibration for vertical oscillations, the spring will execute 200 oscillations in 80 seconds. How many oscillations it does? It does 200 oscillations in 80 seconds. Okay, how many oscillations it does? It does 200 oscillation. Okay, clear? No, look here, I'm trying to highlight. It is doing 200 oscillations in 80 seconds. With this information, you have to calculate the force constant of the spring. Again, the same approach. What is that? Break that into three parts. One is list out all the things that are given to you. Second step is going to be list out all things you are supposed to find. The third one is going to be the solution part. Okay. Likewise, for this problem, what are the things that is given to us? Look here, I will extract this. So what has been given to us? And when you are listing out, what you have to do, convert all things that are given to you in SI units. Okay, look here, this is the given data. I'll go for a new file. Okay, what are the things that are given to us? Shrink it. Yeah. What are the things that are given to us? The things that are given to us are, look here, mass of the spring is given. So what is the mass? 15 kg. It is already in SI units. And how many oscillations the spring is going to make? It is going to make 200 oscillations. And what is the time taken by the object to perform those 200 oscillations? It is 80 seconds. It takes 80 seconds. Okay, no, these are the things that are given to you. What are the things given? Mass of the object is given, number of oscillations is given, and the time taken to perform 200 oscillations is given. Everything or that has been listed are already in SI units. Okay, clear? Next, what you are supposed to find? What we are supposed to find is the spring constant. What you are supposed to find? What I am supposed to find is A is equal to spring constant. Okay, what you are supposed to find? You are supposed to find the spring constant K of the spring. Okay, so how do I do it? How do we do it? So therefore, look here. First, what you do is you find the time period of oscillation. All of you are with me?
Yes, sir.
Or people with me? Or people with me?
Yes, sir.
Okay, good, great. Okay, now look here, try to understand what I am telling. Keep all your calculators aside. Okay, when I tell you, show me this by this, then you punch numbers and give me the result. Okay, until then, understand the art of cracking a problem. Okay, understand the technique behind solving that problem. Okay, therefore, look here. First thing what we do is, you find the time period of oscillation. Time period of oscillation is given by what? T is equal to, capital T is equal to time taken, that is small t, by number of oscillations. What is that? 80 by 200, which is 0.4 seconds. Okay, so first let me write this part here. So what is the time taken by the object to perform what is time period? Time period is time taken by the object to perform one oscillation. I will find this here. So this we will work it out. Okay, look here. I think I'll extract this. My mouse is always a problem. Yeah, first let me take this and put it here. Okay, so I can shorten it. Okay, so what did I do? First found the time period T. Time period T is nothing but what? Time period T. This is equal to small t by n. So therefore 80 by 200 will give me 0.4 seconds. This will work it out later. First understand. Okay, now T is known. Okay, next, what is the relationship? What is the formula that connects spring constant K and the time period T? It is this formula. Okay, time period T is equal to 2 pi divided by square root of m by k. What is the relationship that connects them? It is this. Okay, all of you are with me? All students are with me?
Yes, sir.
Yes, sir.
You know,
Yes, sir.
right? All students are with me?
Yes, sir.
Yes.
Yes,
Okay.
sir.
Now understand what I am telling. Okay.
Yes,
Time
sir.
period T is found. Okay. The common mistake that students generally do is what? Look here. Time period T is known, and that is given in this formula. Time period T is given, that is found, and T is related here. But what you are supposed to find? What I am supposed to find is K. What you are supposed to find is K. K is here. Correct? No? Right? So what generally students do is they will start plugging the value T, capital T equal to 0.4 here itself. I will show by a different color. Okay. So look here. Students will directly start plugging the value T equal to 0.4 here. What generally students do? They take the basic equation. This is correct. Basic equation is correct. But what do? You start plugging capital T equal to 0.5 here itself. But what you are supposed to find is K. K is somewhere hidden inside the tunnel. Got my point? No? Right? Got my point?
Yes, sir.
Yes,
What does
sir.
that mean? What does that mean? I'll give a simple demo. Okay? I'll give a simple demo. I'll use a new window so that I don't collapse. I don't close this browser, active browser. I'll minimize this. Look here. So this is a browser. I have opened some 2-3 tabs. Okay. I opened 2-3 tabs. Correct? All of you are with me?
Yes,
All
sir.
students are with me? Okay. Now look here.
Yes, sir.
I'll close this. I'll go to my demo browser. Yeah. So look here, this is browser 1, this is tab 2, and this is tab 3. Okay. Somewhere here, I will be doing some bank transactions. Okay. For example, I'll be doing some bank transaction. I want to make an online transfer of my money. Okay. For example, say ICICI Bank. Okay. The browser will open. I will log in and I will initiate a transaction. Okay, all of you are with me?
Yes, sir.
Yes, sir.
Yes or no? Okay, why I'm trying to tell is the following. Okay,
Yes, sir.
so browser will open. I will log in with my login credentials. Okay, I will do all that. Then I will initiate one transfer. Okay, for example, I may want to transfer my money to my cousin. Okay, all their IDs or accounts numbers are already there in my ID. So when I do it, what will happen? first what will happen is a OTP will come. One time password will come. All of you agree with me?
Yes, sir.
OTP will come, no?
Yes,
Right?
sir.
And
Yes,
that
sir.
OTP you have to feed at the right place. Yes or no?
Yes, sir.
Correct? No, everything's now
Yes, sir.
interconnected. Okay, without handset you cannot do anything. Okay, OTP will come that will validate your mobile number that is mapped to the bank ID or to Aadhaar number. So therefore it is an interface, essential interface. Okay, OTP is going to come. Correct?
Yes, sir.
Yeah. Now the OTP generally it will be valid for online transactions only for 90 seconds. 90 seconds. Okay. In other cases, it may be valid for 15 minutes. We'll not worry about that. OTP has come, so you have to quickly do it within 90 seconds, 1.5 or 2 minutes. Now you don't know in which browser you have initiated the transaction. You got the OTP in your handset, for example, 1976, and you don't know in which browser you have initiated your transaction. Correct? Right? So by the time you know, oh, it is there in this browser, by the time you know, extract it, and if you try to feed it here, what will happen? The time of validity of that OTP will lapse. Correct? Am I right? Yes or no?
Yes, sir.
Correct? Right? So therefore you should be quick enough to know in which browser you have initiated the transaction and feed it precisely there within say 10 or 30 seconds. 10 to 30 seconds is a good time. Okay, 10 to 30 seconds. 10 30. Okay, you got my point. Is it clear? If you don't
Yes,
do
sir.
it, what will happen? It will lapse. Right? Likewise, okay, I'm spending more time in telling how to do things in the right way. Okay, likewise, okay, I will undo all the other stuffs. Okay, so what generally the students do, is you get that value here, t you got t here, and you will directly start substituting here. You will directly put your OTP in a wrong browser. Don't do it. Is it clear? Okay, because what you are supposed to find is K. K is here. Okay, K is here. Therefore, first what you do, it will take only 1 or 2 extra mathematical steps. First what you do, express your quantity in question in terms of known quantity, and substitution should be the last step. Understood? Inserting OTP should be the last step. Okay, clear? Understood? Therefore, what do I mean? Look here, this is my basic equation. I will write it in a doc file. Okay, look here, it will just take only 2 minutes. Okay, so look here, suppose I go to a doc file. Okay, next steps and all I will tell. If you do like this, the formula is given by this. I will skip like that and go. Therefore, here only in first 2 problems, I am spending time in detail. Okay, look here, what is given by T is equal to, capital T is equal to, what is that? 2 pi, 2 into pi. I will increase the font size. 2 pi into, so square root, I will write it as SQRT. Okay, square root of m by k. Okay, small m divided by k. I'll close this bracket. Look here. Okay, understand, when we work it out, it will just take only 2 minutes. If I increase the font size to say 30. Okay, what is the time period given by? Time period is given by t is equal to 2 pi into square root of m by k. But what you are supposed to find is k. Right? You're supposed to find k. Therefore, don't put the value of t directly here. Don't put the value of t directly here, or don't put the value of m directly here. Okay, first what you do, express this k in terms of known quantity. For that, what I have to do, you have to square on both sides. If you square on both sides, what you will get? If you square these both terms on both sides, what you are going to get? What I am going to get is, look here, if I square on both sides, it will just take only 1 or 2 mathematical steps. Okay, clear? So if I square on both sides, what I'm going to get on the left side, it's going to be t square. T square will be equal to 2 pi will become 4, pi will become pi square, pi will become pi square, and square root of m by k, that will become just m by k. Okay, that will simply become m by k. Just let me write it as m, this whole divided by k, whole divided by k. So how will I write? Let me write it as like this. Okay, to make things more simple, let me write like this. Okay, m by k. Okay, correct? Now what did I do? I simply squared on both sides. I just simply squared on both sides of this key equation, that is this, and I ended up getting this equation. I ended up getting this equation. Okay, now what will happen? Look here, you have to find k. This k will go to the numerator. Suppose I print the screen. Sure. Now look here, what will happen? What will happen to this k? This k will go to the numerator here. Look here, this k will go to the numerator and this t square will come in the denominator. That's all. Therefore, small k is equal to 4 pi square m by t square. That is what is precisely this formula. Okay, where is that? That is what precisely is this formula. K is equal to, okay, k is equal to 4 pi square m by t square. So that you plug in here. You got my point? Okay, so now enter your OTP within 3 seconds. Within 3 or 5 seconds, your transaction is going to be successful. Understood now? Got my point? So what is the expression for time period? Sorry, what is the expression for spring constant given by simply squaring this equation on both sides and rearranging, I will get an expression for spring constant k, and spring constant k is given by 4 pi square m by t square. You see that in this step, my quantity in question has been expressed in terms of known quantities, and to go from this step to this step, I just took only 1 or 2 mathematical steps. Got my point? So what you have to do, once that is done, plugging in the value in this key equation should be your last step. Understood? Feeding the OTP in the right browser should be your last step for making your transaction to be successful. Got my point? Is it clear? Therefore, don't blindly start plugging the values in this equation. It is premature. Don't plug in the values in this equation, which is a premature. Okay, this is our required equation. Okay, clear? No? Therefore, understood? Therefore, now plug in the values. What you are going to get? Look here, now I'll plug in. I will take this whole content. Okay, I'll take it in a new folder. Save. Okay. Okay, I think I can put it here. I'll expand this. Okay. Now tell me what is the value you're going to get. Now look here, I have plugged in. What is the value you are going to get? So k is equal to 4 pi square m by t square. 4 pi square m by t square. Now I have plugged in the values. This is in the numerator and this is in the denominator. So what you are going to get? So will someone work out? Will you work it out now?
Sir, 3697.35 Newton per meter.
Yes. Okay. Yes. So final answer is going to be k is equal to this. Okay. If I put it here, suppose I use red color. Final answer is going to be k is equal to 591 by 0.16, which is 3697.35 Newton per meter. Is this clear to you all? Okay, look here, I spent around roughly 12 minutes. Okay, don't plug in the values here itself. Just express the quantity in terms of quantity in question in terms of known quantities, and plugging in the value should be your last step. Once that is done, it becomes easy for you to arrive at the right solution or the right value. Okay, clear to you all? So that ends the second problem. In the next class, we will work out another three or four more problems, and that will end up the module 1. I mean, module 1 means it is the oscillations and oscillations chapter. Okay, clear to you all? So before that, let me